Einstein shared with the student his burning desire to understand the universe. "I want to know how God created this world," he said as they strolled along. "I'm not interested in this or that phenomenon, in the spectrum of this or that element. I want to know his thoughts.
Me too.
The rest are just details." This one conversation expresses the core of Einstein's guiding principle, one that has driven humanity to inquire, discover, experiment, and most importantly, learn about this universe we call home. But what was Einstein really talking about? And can human knowledge ever reach a point where we understand everything?
Indeed. I want to know everything. Talk to me.
Since the discovery of the world of quantum mechanics in the early 20th century, scientists have been racking their brain trying to understand how it works. Even a century later, we're still not sure how and why subatomic particles behave the way they do.
Indeed.
But that's just half the problem. The discovery of quantum theory posed a more serious issue that Einstein, Stephen Hawking, and other world-renowned physicists have been working tirelessly to solve.
Bro, you know, I heard that Stephen Hawking was not always in that wheelchair, bro. And that baffled my mind. Because that's all I remember him with. Well, that's all I remember him as. In the wheelchair, bro, which is insane.
That challenge can be summarized in
It's kind of fucked up.
Unification. You see, modern physics is split into two pillars. Classical physics, the physics of Newton, Einstein, and Galileo, which predicts gravity and describes the motion of massive things in our cosmos like stars and planets. And quantum physics, which governs the world of subatomic particles according to its own set of laws and rules. Both pillars describe their respective worlds accurately, but fail when applied to each other's subject matter.
Hi, we're Offer Pack.
Bro, I ain't gonna lie, I was really like invested in that, and they hit me with this dog shit ass
Einstein's
ad.
preoccupation was that there must be a way that these two worlds could reconcile. There has to be a theory that unifies the world of the subatomic with the world of the massive.
Indeed.
A theory that can predict
Everything.
Well, everything.
Come on, bro.
Now you might be thinking,
I'm a scholar,
so why
bro.
should we care? Well, a unified theory that can bridge both of these worlds could potentially unlock many of our universe's secrets and answer some of the deepest philosophical and theological questions that we've been asking since the days of Galileo. What are we truly made of? What happened before the Big Bang?
Oh my god,
Are we
bro.
living in a multiverse?
Bro, y'all know, bro. I heard that matter only makes up like 1% of the universe, but everything's made out of matter. You know what I'm saying? And that is crazy to even think about. Like, everything that we can, like, touch, feel, like, see is made of matter. But it's only 1% of the universe. Or something like that. Some bullshit like that. Which is, like, I ain't gonna lie, there's some Doctor Strange shit going on, bro. That we don't know about.
Verse. The unified theory, or the theory of everything, might just have the answers to all of these questions. The universe and everything in it is glued together by four fundamental forces.
Oh, I learned this in science, bro. Dang, I should know this. I know it's gravity. And then there's one word that's like, it's like two of them. I can't remember what it's called. It's almost, I don't remember. I know one is gravity though.
I made an
Gravitational
entire video on
pull,
these
I
four
should
forces,
say.
So if you really want to fully understand all of them, I suggest you check it out. But for the sake of this video, here is the gist of what they do. Big objects like stars, planets, humans, and cats are all governed by the force of gravity. And thanks to Einstein and his general theory of relativity, we now know that gravity isn't a force that magically pulls objects together. Instead, it's the curving and warping of the fabric of our universe, space-time. While all these big objects are governed by just one fundamental force, subatomic particles, on the other hand, are governed by three fundamental forces, as if they weren't already confusing enough. These three fundamental forces are electromagnetic, weak nuclear...
That's what it is. Weak nuclear force, strong nuclear force, electromagnetic, and gravity. Those are four, I believe.
And strong nuclear. Electromagnetism holds atoms together. The strong force holds nuclei together. and the weak force is responsible for some type of nuclear decay. These particles, along with their respective forces,
Looks like a rose.
make up what we call the Standard Model. The Standard Model describes the world of the very small. We know that everything in the universe is made of subatomic particles, from planets and stars to humans and dogs. We know that all of these things are made of atoms, and atoms are made of protons, neutrons, and electrons.
Yes, sir.
In the 1960s, we discovered that even protons and neutrons are made of even smaller particles called quarks, and
Hey, yo, bro, don't tell me my hero is real, bro. Don't tell me my hero is real, bro. Oh my god, bro. Don't let me find out, bro. I will hone my powers and skills, and I will be him. I'll be the real world's All Might. But except for being strong, I don't know. I'll be like Todoroki on some shit. You feel me? That nigga Todoroki's gas.
electrons from leptons. Using different
I heard
combinations
about
of these
leptons.
particles and their respective forces, we can build atoms, molecules, humans, planets, and even stars. So it seems that the Standard Model is a comprehensive interpretation of our universe. But it doesn't include everything. The truth is, finding the smallest subatomic particles is only the first step to getting to a theory of everything. The second step would be finding a place for gravity in this model. There are two reasons why gravity isn't included. The first is that when it comes to small particles, the force of gravity is so weak
exactly.
that it doesn't have any effect on a quantum system. The second reason is that we don't really know how to incorporate general relativity, which describes the motion of large objects, into the world of quantum that governs subatomic particles. Many great minds, including Einstein, tried tirelessly. It's said that even on his deathbed, Einstein revisited his notes on the theory of everything and tried one last time to find an elegant solution to explain the fundamental differences between the world of the small and that of the large.
Hey, I ain't gonna lie, that's
But
respect.
unfortunately, he ran out of time.
That is respect.
So that's that, right? we still
Nigga was
haven't found a
thinking to the
theory
end
that
of
can explain
time, bro.
everything.
Well, to the end of his
We
time,
have
bro.
made significant progress, and maybe the most groundbreaking was that of another brilliant mind, Stephen Hawking. In 2014, a movie was made on the impactful life of Stephen Hawking. As a result, Hawking became one of the most revered physicists in the world, and one of the most admired by pop culture.
Before we were using Monday.com,
Bro,
our
I
team
swear
was
he
rowdy.
wasn't always in the wheelchair.
Our
What?
days used to split between work.
I don't know. It must have been
Away
fibbed
from
to,
the
bro.
limelight, however, Hawking, like Einstein, had an obsessive yearning to understand the universe and never ceased to challenge our knowledge of it. One of his greatest contributions was the discovery of what is now known as Hawking radiation. In 1974, Hawking discovered one of the biggest breakthroughs of the 20th century, a groundbreaking interpretation of black holes, as well as an unprecedented interaction between the world of quantum and gravity. Hawking's discovery was so ingenious that it gave us hope that the theory of everything, the holy grail of physics, is still a human possibility. Black holes are densely packed regions of space where the gravitational pull is so strong that nothing can escape, not even light.
Yeah.
Einstein predicted the presence of black holes through his general theory of relativity in 1916, and we confirmed his predictions in 1974 when we observed our first black hole in the Milky Way. In the same year,
Nah, that's crazy.
Hawking
It was a
discovered that black holes are like a vitamin tablet placed in water. They can dissipate in time and release energy. This is what we know
Nah,
as
that's
Hawking
crazy.
radiation today. But how can energy escape a black hole when nothing else can? Hawking used a quantum understanding to explain this. When we think of space, we imagine large, cold, empty places, but in reality, space is
not.
alive with the active creation and destruction of energy at the subatomic stage.
Yeah.
Particles are created in pairs, matter and antimatter, and they are constantly created and destroyed in a concept known as annihilation. Hawking imagined a
that
pair of
sounds
particles
brutal.
created
Holy
very
moly.
close to the event horizon of a black hole. This is the boundary around a black hole from which nothing can escape. He then showed that these particles don't need to annihilate each other, since one of them can be sucked into the black hole. If the black hole is receiving negative energy, then it has to release energy in order for the law of conservation of energy to hold.
Indeed.
Hawking also proved that black holes lose mass with time, and they don't last forever. But more importantly, he was able to arrive at this discovery by merging a quantum principle with the concept
So
of gravity.
gravity.
This is by far the closest we've come to a theory of everything, a unified field theory, or quantum gravity. But as with most things in science, the fact that we haven't found that one elegant equation does not mean that we have failed. In fact, maybe the real treasure was the discoveries we made along the way, many of which have paved the way for a brighter future for humankind. String theory is one of the most prominent ones.
Oh yes,
It
sir. This
suggests
is
that
one of my
subatomic
favorite, bro.
particles, such as electrons and quarks, are made of tiny vibrating strings or filaments that
String theory. This could definitely. I don't know. This is one of my favorites because it deals with time travel, and that is one thing that I am very interested in. I'm not gonna lie.
twist and fold, creating everything in our universe. Just like the strings of a violin, they can vibrate in various patterns, creating different kinds of particles, including the graviton, a hypothetical particle that, according to quantum mechanics, should carry the force of gravity. On paper, string theory could unite gravity and quantum mechanics under one framework once and for all. The theory was popularized in the 60s and 70s, and its mathematics predicts small bundled up extra dimensions that give rise to a network of universes
Yeah.
or a multiverse.
Yeah.
Well, this theory
Come on, bro. Y'all gotta listen to me when I speak, man. Y'all gotta listen to me when I speak. Cause dog, bro. Because bro, like, I'm really smart, bro. I'm not gonna lie to y'all, bro. I graduated with honors. It wasn't even that hard either, you know what I'm saying? But dog, bro, like, I really be into this stuff, bro. It's real, bro. I believe in all of this shit, bro. But we're not gonna get into that right now. I'll get into it at the end.
is prominent, it's highly untestable, even with access to the latest technology. String theory, though, is only the beginning. After almost 2 decades of tireless research, we've discovered the Higgs boson. This proved that electrons and quarks inside the atom get their mass from an invisible field that spreads throughout space.
Oh, I did not know
The
about
discovery
this.
took an effort from a group of 3,000 scientists that did
Hold on.
throughout space. That electrons and quarks inside the Earth, we've discovered that only the beginning, access to the latest technology. String theory, though, is only the beginning. After almost 2 decades of tireless research, we've discovered the Higgs boson.
Higgs
This proved
boson.
that electrons and quarks inside the atom get their mass from an invisible field that spreads throughout space. The discovery took an effort from a group of 3,000 scientists that dedicated endless hours to the cause that would surely bring our species one step closer to understanding our universe. We've also discovered that all the atoms and light in the universe only make up less than 5% of the total content of the cosmos.
Yeah.
The remaining
Which is
95%
crazy as heck.
is composed of dark matter
Antimatter?
and dark energy,
Oh, that's what I meant.
which
Dark
are
matter.
invisible, but whose effects dominate the evolution of our universe. Dark matter provides the gravitational pull that keeps galaxies together, while dark energy is responsible for the ever-accelerating expansion of our universe. For thousands of years, we've looked to the heavens and wondered what mysteries are hiding beyond the clouds. Since 1970, there have been more than 90 telescopes placed in orbit by NASA and the ESA to bring the universe closer to us. And with the James Webb Telescope that launched on December 25th, 2021, we entered a new era of discovery.
I know about
telescope
this.
is the largest and most powerful one ever built.
I did not know about
And its
this.
daunting task is to find the first galaxies that formed in the early universe, and peer through dusty clouds to see stars forming planetary systems.
How are you gonna?
We may
Fine,
not have
man.
found the theory that unites quantum with gravity yet, but every discovery brings us one step closer to that ultimate goal of unification.
I don't understand how you gonna find that from a telescope. Like I get that. Like I understand that like what we see now. Hold on, I'm just gonna mute this. But I understand that like what you see now is like literally like light years ago. But that's if you're looking at it from here, you know what I'm saying? Like from here. But how if you put a space? I don't know.
Push the boundaries of existence by asking tough questions and working tirelessly to find the answers. Our species has been defined by its incessant thirst for knowledge and unwavering hope in a unified universe. 350 years have elapsed since our first big successful step in this journey, when Newton unified the heavens with the earth, revealing that planets, stars, and apples are guided by the same set of laws. 200 years later, James Clerk Maxwell coupled electricity with magnetism, and then Einstein linked space and time and warped them into one fabric that we now know as space-time. Looking at the timeline of these events, it shouldn't be surprising that the road ahead could be much longer.
Yeah.
Einstein died dreaming of a physical world governed by one set of laws, a unified framework that can unlock the mysteries of our universe, and Hawking never ceased to look up at the stars and wonder what mysteries lie ahead waiting to be found. Whether the theory of everything is a realistic quest or a delusional attempt to make sense of the absurdity.
Hmm? Who? Who? Lil Man. He would love to be here, you know? Yeah, he sure is.
Of the universe, one thing is certain. Our unwavering hope in the search for unification will only lead to humanity's advancement as a species. If you feel you're in a black hole, don't give up. There's a way out.
Wait, what?
If you feel you're in a black hole, it will lead to humanity's advancement as a species. If you feel you're in a black hole, don't give up. There's a way out.
That's crazy. That's crazy. That's how that ends. That's actually
Today's video
insane.
is built in Hopi and searching fandom is some bandwidth and so like
Oh, okay. Nah, that was a W vid, but that was actually great. But my thing is, bro. But do we really want to know that question? Like, you know, some things are just better off not knowing. And I don't know. I feel like the day we know everything will be the last day on Earth. Literally. It'll be the last day of Earth. It's crazy, bro. I don't think we're meant to know. But hey, man. That was a W video.